All right. Good morning, everybody. Um, this morning we are going to consider isotope, just something very small. Isotopes. Isotopes is a phenomenon, excuse me, in which atoms of the same element, they have to be the same element. For example, you have chlorine 17, you have chlorine 17, and they have different mass numbers. Because they have the same different mass numbers, so they are known as isotopes. Whereas the phenomenon itself is known as isotopy. So there's difference between isotopy and isotopes. Isotopes are the individual elements. Isotopes are the individual atoms of the elements. Why isotopy is a phenomenon. All right, so that's what I'm going to consider. I'm considering the phenomenon itself, known as isotopy. So now at this point, we want to look at some of these elements that can exhibit excuse me, isotopy. Number one, hydrogen can do that. So hydrogen 1 and 1, we have hydrogen 2 and 1, so mass number is 2, this is 1. We have another isotope of hydrogen, which can be 3 and 1. So this one is called proton. So for proton, the mass number is 1 excuse me, the atomic number is 1. Whereas you have 2 and 1, this one is called deuterium. This one is called deuterium. Okay, so why this one is called tritium? So this one is called tritium. Why tritium? Okay, so why this one is called deuterium? So notice one thing, that the mass numbers are different. This one is 1, this mass number is 2, this mass number is 3. So mass numbers are different, but notice one thing, the atomic number is the same. They are 1 1. All right, so now what makes it different in their mass numbers? So pay attention. So remember that number of proton is atomic number, that's 1. Number of electron now is the same because it's a neutral atom. 9 neutron, the number of neutron is 1 minus 1. That means mass number minus atomic number. That means 1 minus 1. That's going to give us 0. So for proton, it has proton number of 1, electron number of 1, but the neutron number is 0. Which of the following isotopes of hydrogen does not have neutron? The answer is this one, 1 1. There's no neutron there. Let's go to the next one, which is 2 and 1. So this one, the number of proton is 1, number of electron is 1, then 2 minus 1, that is neutron, is 2 minus 1. So answer is 1. So for this one, which is deuterium, the number of neutron is 1. So proton is 1, electron is 1, neutron is 1. Okay, so let's move on. We have 3, the third isotope of hydrogen. The mass number is 3, atomic number is 1. So proton is 1, electron is 1, then neutron is 3 minus 1. If you look at that, neutron is 2. So neutron number is 2 for tritium, and proton is 1, electron is 1, neutron number is 2. No problem. So what are other elements that can exhibit, isotope? You have chlorine. You have chlorine 17 and chlorine 35. Chlorine 17, okay, 35. This one, proton number is 17, electron number is 17, then neutron number is 35 minus 17. Answer should give you 18. Okay, that's that. Okay, so that's one isotope. The other one will be chlorine 37, and you have atomic number is 17. So proton is 17, electron number is 17, and neutron will be 37 minus 17. So answer is 20. Notice one thing, that their neutron number is different. Excuse me. Neutron number is different, and atomic number, proton number, and electron number are the same. All right, so these are the phenomenon of isotope. Which of the following statements is correct about isotope? Number 1, they must have the same proton number. So please pay attention. They must have the same proton number. That's correct. Number 2, they must have the same electron number. That's correct. Number 3, they must have the same atomic number. That's correct. So please pay attention. Isotopes of elements, they have the same proton number, they have the same electron number, and they have the same atomic number. That is that. All right, now, okay, so what do they have as differences? They have different mass number. They have different mass number. Now, because of the fact that they have different mass number, they are often said to have different physical property. They have different physical property, whereas they have the same chemical property. That's that. All right, so the next thing, after laying the example, laying the foundation of isotope, the next thing is we are going to do the calculation of isotopes. Okay, so in the next video, very short, we are going to do the calculation of isotopes.